In 24 through 27, we're asked to define a variable, write an equation, and solve it, and use the solution to answer each question. So in number 24, we have a pipe that can fill a tank in 24 hours and another pipe can fill the same tank in 36 hours. How long would it take for both pipes to fill the tank? This is a classic work problem. 1 over the time for one of the pipes alone to do the job plus 1 over the time for the second pipe to do the job alone equals 1 over the time that it would take them to do it together. So what we can do next is multiply each term by the least common denominator of all the denominators, which is 72 times t. Simplifying each of the multiplications, we get 3t from the first multiplication plus 2 times t for the second multiplication equals 72. That will give us 5 times t is equal to 72, and t is equal to 72 divided by 5, which is better expressed as a mixed number. 5 divides into 72 14 times with 2 leftovers, so that's 14 and 2/5. And 2/5 of an hour is 24 minutes. 1/5 of an hour is 60 divided by 5, or 12 minutes. And so 2/5 of an hour is 24 minutes. So final answer here is 14 hours and 24 minutes. In 25, we have a distance, rate, and time type problem. So in that case, we should probably organize the information using a chart. So reading, it looks like our rates are measured in miles per hour, and that suggests that we should be multiplying by hours to get a distance that's measured in miles. And Sam jogged up the hill at 6 miles per hour and jogged back down. So it looks like we have a trip up and then we have a trip back down to record. So his rate up was 6 miles per hour. The rate downward was 10 miles per hour. And he jogged for a total of 2 hours. Now that's neither the trip up nor down, but a total. So I'm going to write that down below the hours column. And the question is, how long was his path along the hill? So the path going up is something that we don't know its distance or how many miles it is, so we'll call that x. And since he traveled back down the hill using the same path, then his distance down was also x. Remember that the formula up at the top looks like miles per hour, which is a rate, times hours, which is a time, equals miles, which is a distance. If we take that equation and solve it for time, time is equal to distance divided by rate. So that means that the amount of time, or the number of hours going up the hill, is x divided by 6, going down x divided by 10. Now we have a total, which suggests an equation: the time up plus the time down in hours equals the total time of 2 hours. We can multiply both sides, or all terms of this equation, by the least common denominator, which is 30, and then simplify each of the multiplications. 30x divided by 6 is 5x, 30x divided by 10 is 3x, and 2 times 30 is 60. So now we have 8 times x is equal to 60, which gives us x is equal to 60 divided by 8. And let's reduce that fraction by 2. That gives us 30 divided by 4. And then by 2 again, that's going to give us 15 divided by 2. And if you want to give that as a mixed number, that's fine. 7 1/2, or 7.5. And that would be measured in miles, since that's the distance up the hill or down the hill. In 26, the speed of a stream is 3 kilometers per hour. That's a current speed. A boat travels 4 kilometers upstream in the same time that it takes to travel 10 kilometers downstream. What is the speed of the boat in still water? So we have a distance, rate, and time problem. Kilometers per hour times the number of hours should equal the number of kilometers. And we are traveling upstream and then back downstream. And the speed of the stream is 3 kilometers per hour, and we are looking for the speed of the boat in still water. So it's important to remember that the speed of the boat, if it were in still water, could be called x, but if we're traveling upstream, we have to subtract the current speed from it. If we're traveling downstream, we have to add the current speed to it. So x minus 3 and x plus 3 are those rates, upstream and downstream. And the trip upstream was 4 kilometers, and this trip downstream was 10 kilometers. Similar to the previous problem, if rate times time is equal to distance, then the times are distances divided by the rate. So 4 divided by x plus 3 and 10 divided by x plus 3. And it tells us that the times are the same upstream and downstream. That means that they are equal. So 4 divided by x minus 3 is equal to 10 divided by x plus 3. When you have a proportion, you may, which is two fractions that are equal to one another, you may do one of two things. You may multiply it through by the least common denominator, or you may simply write the effect of doing that, which is called cross multiplication. In cross multiplication, also known as the butterfly method, the cross products 10 times x minus 3 and 4 times x plus 3 are set equal to each other. So multiplying 10x minus 30 is equal to 4x plus 12. And so subtracting 4x and then adding 30, we get 6x is equal to 42 and x is equal to 7. So that would be the speed of the boat in still water, which would be 7 kilometers per hour. And that is the answer to the question asked. In 27, we have 2 road crews working together, repairing 1 mile of a road in 4 hours. Working separately, it takes one of the crews about 6 hours to repair a similar length of road. How long would it take the other crew working alone to repair a similar road? This is a classic working alone and working together type of work problem. So it's important to know that 4 hours is our time together, and 6 hours is one of the times alone, and we are looking for the other time alone. So 1 over the time alone for one crew plus 1 over the time alone for another crew equals 1 over the time together. And we can take and multiply each term by the least common denominator, which is 12t. Once we've done that, we can simplify each of the multiplications. 1/6 times 12t is 2t, and 1 over t times 12t is 12, and 1/4 times 12t is 3t. And subtracting 2t from both sides, that gives us t is equal to 12. So the answer to our question is it would take the second crew about 12 hours to complete that same type of project. In 28 through 29, we're asked to solve each equation for the specified variable. So in 28, I'm going to start by clearing the fraction. That is, I'm going to multiply both sides by 3x minus 7. And multiplying by 3x minus 7 on the right undoes the divide by 3x minus 7. So that's what we get. It's important to realize that this is not now solved for x. Yes, as x is alone on one side of the equation, but x is described in terms of the variable y and also in terms of itself. So that's not fairly solved for x. So I'm going to go ahead and distribute the multiplication times y. So 3 times x times y minus 7 times y is equal to x. And then I'm going to gather all the terms with the x on the same side of the equation. So I'm going to subtract the x and add the 7y. That seems easiest to me. Of course, you can do it a little differently, and I will talk about the different answer that's also acceptable. Once we get all of our x terms on one side, factor the x out from that expression, and that will give us 3y minus 1. And then divide, we can divide both sides by 3y minus 1, we get 7y divided by 3y minus 1. Now that's not the only acceptable answer. It is also acceptable to write x is equal to negative 7y divided by 1 minus 3y, and that's just dependent upon whether you move things to one side of the equation or the other. So both are acceptable answers. In 29, we're asked to solve for a, but I'm going to start by clearing all the fractions. So I'm going to multiply all the fractions times the least common denominator of a times b times c. We can, of course, cancel some common factors in each multiplication and then write the simplified result from each multiplication. 4 times b times c plus 5 times a times c is equal to a times b. We're solving for a, so I'm going to move that 5 times a times c term to the other side by subtracting it, and then factor out the a, and that gives us b minus 5c. So a times b minus 5 times c is equal to 4 times b times c, and now we can divide. And if we divide both sides by b minus 5c, then we get a is equal to 4 times b times c divided by b minus 5 times c. That is one acceptable answer, but another one is a equals negative 4 times b times c divided by 5c minus b. Both are acceptable answers. It just depends upon which side of the equation you moved things to. In 30, we're asked to find the constant of variation and the equation of variation that relates the variables. So t varies inversely as the cube of z and directly as the square of r. So t varies inversely, that means equals k divided by the cube of z, and directly as the square of r, so that would be times r squared. So that is the equation of variation. However, that is not the complete variation equation because it doesn't include the variation constant, which is what we're about to find. So I'm going to take my equation and I'm going to replace the values of the variables with numbers. So whenever z is equal to 3, so I'm going to put a 3 cubed on the bottom there, and the r value is 6, so 6 squared upstairs. We don't know the value of k, that's what we're trying to find out. And then that's equal to t, which is 4. So, simplifying, we have 4 is equal to 36 times k divided by 27. I'm going to do a little reducing on the right side of the equation. Both of those numbers are divisible by 9. So that's going to give us a 4 times k divided by 3. Now that's going to be easier to multiply both sides by 3. 12 is equal to 4 times k, and then k must be equal to 3. This is known as the constant of variation. So if the constant of variation is requested, that's all we're looking for. Now the equation of variation is what we wrote at the beginning, but with that value inserted. So the variation equation is t is equal to 3 times r squared divided by z cubed, because that is the equation that relates the variables that are described, z, r, and t. In 31 through 33, we're asked to write an equation of variation and use it to answer each question, including units in your answers when appropriate. So in 31, suppose that r varies jointly as s and t and inversely as w. So I'm going to take that piece of information there and translate it into a variation equation. So r varies jointly as, that means equals k times s and t, so times s times t, and inversely as w, so divided by w. We're given information about values of the variable that go together, so r is equal to 20 whenever s is 5 and t is 4 and w is 2. So 20 is equal to 20k divided by 2, or 20 is equal to 10 times k, so k must be 2. That's our variation constant. So the equation of variation is r is equal to 2 times s times t divided by w. And then we're going to use that to find the value of r when s is 15, t is 8, and w is 3. So from here, we're looking for r, and we know that s is 15, t is 8, and w is 3. So r is equal to, we can do some canceling here, common factors. Now it's just 2 times 5 times 8, so that's going to be 80. In 32, the speed s of an object falling from rest, so s varies directly, that means equals k times the square root of the distance, so square root of d, that the object has fallen. When the object has fallen 36 feet, so that would be a value of d, the distance it falls, its speed is 48 feet per second, so I'll replace s with 48. So it looks like 48 is equal to 6 times k, and that gives us a k equal to 8. And so from here, our variation equation is s is equal to 8 times the square root of d. That means that I can find s whenever I'm given the value of d, now that I know the value of k. All right, so what is the object's speed? So we're looking for s after it has fallen a total distance of 100 feet. So that means the d is 100. So that's 8 times 10. So s is equal to 80. And s is a speed. What were our speeds measured in? They were measured in feet per second. So that's important to include those units in your answer. All right, in the last exercise, the current I flowing in a wire is inversely proportional, so that means equals k divided by the resistance R of the wire. The current is 3 amperes when the resistance is 20, so current is I, so I'm going to put a 3 in for I, and I'm going to replace the value of R with 20. So k divided by 20 is equal to 3. We can multiply both sides by 20, and that gives us a k is equal to 60. So that means that I is equal to 60 divided by R. And we are asking for the resistance when the current is 12 amperes. So I'm going to replace I with 12. And so 60 divided by R is equal to 12. Multiplying through by R, 12 times R is equal to 60, and R is equal to 5. And R is the resistance, and our resistances are measured in ohms. So that final answer here would be 5 ohms.